Hi, this is Wendy. In this video series, we'll look at selections or if statements. In the first video, we looked at single and double-sided selections. In this video, we'll learn about multi-selections and the switch statement. In the third video, we'll see how nested selections work, and in the last video, we'll look at some common errors that programmers often make with selections and how to avoid them. In the previous video, we talked about single-sided selections, which allow your code to perform an action or set of actions if the value of a Boolean expression is true. And also double-sided selections, which present an additional alternative set of actions to perform if the Boolean expression is false. In this video, we'll look at a multi-sided selection, which allows you to perform actions based on multiple conditions. For example, a multi-selection will allow you to determine the cost of shipping a package to different provinces. For example, if that package stays in Ontario, you might charge 75 cents per kilogram. But if the package is going to Nova Scotia, New Brunswick, or PEI, we would charge $1.50 per kilogram. Or instead, if the package is going to Manitoba or Saskatchewan, we would charge $1.75 per kilogram. Or if the package is going to Newfoundland, Alberta, or British Columbia, we'd charge $1.95 per kilogram. And lastly, if the package is going to none of these destinations, but to somewhere else in Canada, charge $2.15 per kilogram. Here's the general form of a multi-sided if. Note that it starts with an if block and is then followed by a series of else if blocks. And at the bottom is an else block. This type of selection can have any number of else if blocks, and the else block is optional. The multi-sided if functions by first evaluating the first Boolean expression in the if block. If that condition is true, then the first code block executes. But if that condition is false, then the program flow moves down to the first else if block. That condition is then evaluated. If it's true, then that code block is executed. But if that condition is false, control moves to the next else if block. The program continues in this manner until it either reaches a condition that's true, in which case it executes that code block and then leaves the structure entirely, or it runs out of if-elses to check. If it runs out of conditions to check, it will then move to the else block and execute the else block's code. If there is no else block, then the program flow moves to the statement immediately after the entire multi-sided selection structure. Let's look at an example. A package's shipping cost depends on its weight in kilograms according to the following chart. Write a program that asks for the weight in kilograms and then calculates and displays the total cost of shipping. So I've got a program ready to go that's already gone ahead and set up a scanner. What I want to do is I want to retrieve the weight from the user. So I'm going to make a little prompt. And then since package weight could be a floating point value, I'm going to use a double. It is more efficient, as we know, to use a double and not a float because double is the default type for floating points. So that's the easy part. Now comes the fun part. I need to determine the shipping cost. You might be tempted to start your if and else if and just calculate in each block. And I think we've talked about this before. It's actually a better idea to set up a variable and then assign the cost to the variable and then calculate once at the end. So I'm going to set up a double cost equals 0. And then I'm going to start off with an if. So a multi-sided if starts with an if block, and then we would have a series of else if blocks, and then possibly an else block as well. So if we look back at our chart, we see that we have the first grouping basically is for when the weight is less than 5 kilograms, then it's 40 cents per kilogram. So I'm going to start off with my first condition. If the weight is less than 5, this one should be pretty easy. Then don't forget to open and close your brackets and braces. I'm going to assign 40 cents to the cost. The next thing I want to check is the 5 kilograms to 10 kilograms range. That's 45 cents. So 5 kilograms to 10 kilograms. Since my first one is less than 5, it's kind of implied that this is going to include the 5. And since it looks like if you look through the rest of them and then the last one says 50 kilograms or more, that seems to imply that this top value 10 is not included, that it would be included in the next range. So less than 5, and then this one is going to be 5 up to but not including 10. And then we'll do the same pattern for the rest of them. So from 5 up to but not including 10. So you might be tempted for your else if to say, okay, if the weight, so it's from 5 up to but not including 10. So you might be tempted to say weight if it's greater than or equal to 5, and we've done these kind of checks between two values before, weight is up to but not including, so less than 10. However, this is actually incorrect. It's inefficient. We don't have to check and see if the weight is greater than or equal to 5, because if weight was not less than 5, then it must be greater than or equal to 5. If we get to this point in our code, it means that weight less than 5 is false. So it must already be greater than or equal to 5. We don't have to ask if it's greater than or equal to 5. We know if we got to this point, it must already be known that it's greater than or equal to 5. So it's inefficient to add this extra condition. Not only are you doing an extra operation, the greater than or equal to, you're also doing an and when you don't need to. So this has two extra operations happening that we don't need. So that would be incorrect. We can actually take that off. Whoops. So we don't need to ask if it's less than 10 and greater than or equal to 5. It's not necessary. If we get here, then it must already be known that it's greater than or equal to 5, because if it wasn't, we would have already determined the cost and we'd be gone. We'd have left by now. So don't add inefficient conditions to your if or your else ifs and your else blocks. It's just not efficient at all. So that one was, I believe it was cost equals 0.45. There we go. And then if we look at our next range of values, we have 10 kilograms to 20 kilograms. So following the same pattern, it's going to be from 10 up to but not including 20. So this one, else if, so from 10, so greater than or equal to 10, we don't have to check that. We know if we got to this point, we must already know that it's greater than or equal to 10. I only have to ask then if it's less than 20. This means that things are actually going to get pretty easy to fill out the rest of it. You can see there's a pattern following here, except that I should actually just be making these floating point numbers because it's more efficient. You don't have to, but it's a good idea. And I forgot to look at the cost. It was 0.48. So there we go. So that's the first three. The next one, 20 to 50 kilograms. So from 20 up to but not including 50. So again, else if, we don't have to ask if it's greater than or equal to 20. It must already be greater than or equal to 20, or we wouldn't be at this point of our code. We only have to check and see if it's less than 50. And there we go. In which case our cost was 0.52. Whoops, that should be an equals. And then for the last one, we can think of 50 kilograms or more is kind of like 50 to infinity. And I don't really know if we want to write an expression that says if it's less than infinity. So instead, we can just put an else here if it's anything else. So if it's anything else that's not one of these conditions, then it's going to be 55. So equals 0.55. And then after your else if, what'll happen is one of these conditions will be true, hopefully. So if the user enters 3, then weight less than 5 will be true. It'll assign 0.4 to the cost, and then it leaves the structure. So once it finishes executing a code block, it then exits the structure and goes to whatever line you have after the if down here. If the user entered, say, 15, then is 15 less than 5? Nope, that's false. So we would go to the next one. Is 15 less than 10? Nope, that one's not true. That one's false. So we go to the next one. Is 15 less than 20? Yes, it is. So this one's true. So we would assign 0.48 to the cost, and then we finished this block. This block is right here. We finish this block, we exit the entire structure, and continue with the rest of the program. If the user enters, let's say, 100, so is 100 less than 5? No, we move on. Is it less than 10? No, we move on. Is 100 less than 20? No, we keep going. Is 100 less than 50? No. So since none of these were true, then we have to do the else block. So the else block will automatically execute when basically none of the above are true. So in this case, cost gets a value of 0.55, and then we finish the if statement. So hopefully that helps you understand a little bit better of how it actually works. All that's left to do, now that I have the cost, I can now calculate the total cost, which is going to be the weight times the cost I determined. Notice that, and I think I mentioned this in the previous one of the previous videos, we don't want to calculate this inside each block. Because if we change the formula of how we calculate, maybe we had to add some things and take a percentage of something, we don't know. We would have to edit that calculation inside each block, and you might miss one. And plus, even if you don't miss one, it's a bit of extra work. Whereas this way, we only have to change one line of code. So it's also more efficient, but it's easier to edit or modify or maintain if we make sure that the if, else if, or the multi-sided if is only doing the minimal amount of tasks. In this case, we only need it to find out what cost to use. So that's all it should be doing. It should not be calculating. We want to make sure we have the minimal amount of code inside our if and else blocks. So all we do, the minimum thing we need to do is assign a cost and then put that cost in our formula. I also, just a heads up, I should be using constants for all of these values, but as you can imagine, that's pretty tedious, and I didn't want you to sit here and watch me type for 10 minutes making constants. But in real life, obviously, I should create, actually, not just constants. In semester 2, you'll learn something called an enum, which is when you have a whole bunch of constants, you can use an enumeration. It's way cooler. If you're interested, let me know. I can give you notes on how to do this from my semester 2 course. It's actually really easy. So anyways, output. So I'm just going to output total cost with a nice little $sign and then %.2f. Don't forget your new line, and then total cost at the end. So there's my else if structure that determines the cost per kilogram. And then after we determine the cost, we then calculate and display it. So let's save, compile, execute, and give it a try. So I'm going to try a little bit of everything so we can make sure it works. So if I enter package weight, I'm going to try, let's say 4 kilograms. So I'll enter 4, and it says the total cost is 160. If you can't do the math in your head to test it out, you can grab a calculator, but that one's easy because it's 40 cents times 4 kilograms. So we know 4 times 4 is 16, so $1.60. And if I try it again, and this time I'll put something in the middle range. So I'll try, for example, I'll try 10. So we know 10, we get 480. So that falls into this range here because 10 is not less than 10, but it is less than 20. So remember we talked about that before. And then we'll try one more. I'll try, what was the one I had before? 100. So I'll try 100. So that should fall into the else block. There we go. So $55 because it came out to 55 cents. There we go. Now note that like single-sided and double-sided ifs, I'm not actually going to do this to each one, but you'll get the idea. You can leave off the braces. This is why. But you can leave off the braces. The same rules apply. If there's only one line of code inside the if or the else if or the else block, you can actually leave off the braces if you want to, or some of them or all of them. As long as they match, you're good. Actually, that one doesn't match. So, but yeah, you can actually leave the braces off. But as I mentioned before in the previous video, it is a good idea to leave them on just in case. If I come back and start adding code, if I come back and start adding code, then I might forget to put the braces on once I do actually need them. So I recommend leaving the braces on. I will almost always leave them on when I do these videos. Now, this program that we just wrote uses what's called a range check. We have a series of ranges, and we have to determine which range our input falls into. It's really easy to mess up a range check. Now, notice that in this example, I started with the lowest range and worked my way to the highest. I started with if it's less than 5, and then else if it's less than 10, and I worked my way up to the highest range. When you want to perform a range check from the lowest range to the highest range, you always compare to the highest number or highest value in each range. For example, the first range was labeled as less than 5 kilograms. Now, this has an implied range of 0 kilograms to 5 kilograms. We didn't actually do any error handling. In the program that we wrote, the user could have entered something negative, but we're going to deal with that another day. We're not going to worry about that today. We have to learn about nested structures before we can handle that. So this has an implied range of 0 kilograms to 5 kilograms, and the highest value in that range is 5. Therefore, my condition compares weight and 5, and I use less than because it actually says the range is less than 5 kilograms. Therefore, my condition was weight less than 5. In the next condition, and this was the first else if block, we had a condition of weight less than 10. So here the range is 5 kilograms to 10 kilograms, and 10 is the highest value in that range. So my condition is weight less than 10. My next condition was weight less than 20. My range is 10 kilograms to 20 kilograms. And again, since 20 is the highest value in that range, my condition becomes weight less than 20. The last condition was for the range 20 kilograms to 5 kilograms, and once again, 50 is the highest value, so we used weight less than 50. And for the last range, it just said 50 kilograms or more, so this is an implied range of 50 to infinity. As we said, I can't really use infinity as the highest value in that range. I can't write a condition that compares weight to infinity, so instead, we just use the else block to say, if it's anything else, we assign 55 cents or whatever it was. Now, if I wanted, I could have done this range check from highest range to lowest range. For example, I might choose to do this if I happen to know that more people shipped larger packages, because what that would mean is if I put my larger checks at the top, so start with the 50 kilogram or more range, and then the 20 to 50, and then the 10 to 20, then it means that my program would have fewer conditions. For example, in this version of the program, if I want to go from low to high like I have here, if a lot of my packages fell in these higher ranges, it means a lot of the times I'm checking, and then I'm checking, and then I'm checking, and then I'm checking before I find the one that's true. So I have to do a lot of checks to get to the more common answers. If I did it the other way around, for example, if I put the higher ones up here and had the lowest ones at the bottom, then I would find the true one pretty quickly, and I would have fewer ifs and else ifs to have to evaluate. So you may choose to go from low to high or high to low if you happen to know that one might be more efficient than the other. So to go from high to low, I would simply compare my input value to the lowest value in each range. So for example, in the if block at the top, I would start with the highest range, which is 50 kilograms or more. And as we said, that's an implied range of 50 to infinity. The lowest value in this range is 50, so I need to compare the weight to 50. And since we know that the input is 50 kilograms or higher, then it would be the greater than or equal to, because it includes 50. So my first condition would be if the weight is greater than or equal to 50, that's the 55 cent range. My next range is the 20 to 50 kilograms. Now the lowest value in this range is 20, and I know this includes 20, so my condition would be weight greater than or equal to 20. My next range is 10 kilograms to 20 kilograms, and of course the lowest value in this range is 10, so my condition is weight greater than or equal to 10. And then the next range is the 5 to 10 kilograms, and the lowest value would be 5, so I would use weight greater than or equal to 5. Now this next one gets a bit awkward. My last range is less than 5, which is an implied range of 0 to 5. So if we wanted to, we could actually just add another else if and say else if weight is less than or equal to 5, and then we could have our else block for the 0 and negative values, and that would be some really good error handling. Or we could just use an else block to deal with anything that's less than 5 or anything that doesn't match any of the previous conditions. Now, personally, I actually prefer the first option, but we'll have to learn a bit more about program structures before we can do that properly. So for now, we'll just use the else to handle anything less than 5, and we'll assume the user won't enter 0 or less. So if I wanted to code that, and you can edit this, or if you want to keep it, you can comment it out. That's probably what I'm going to do here, just so we don't get rid of it. So if I wanted to code it the other way, from highest to lowest, I would start off with, my first one is anything that's 50 or higher. So if the weight is greater than or equal to 50, and that was my 55 cents. I can't type today, it's one of those days. And then my else if. So my next condition, that was the 20 to 50. So I want to compare it to the 20 because that's the lowest value. So again, what I want to know is if the weight is greater than or equal to 20, so weight greater than or equal to 20, and less than 50. But I don't have to say and less than 50 because I already know if I get to this point, then this condition up here must have been false. Otherwise, I wouldn't be here. So if weight greater than or equal to 50 is false, that means the weight is less than 50. So I don't need to also check here that it's less than 50. I already know that. So again, don't add unnecessary conditions. It slows down your program, especially if, this was inside a loop, which we'll learn actually after the break week, and it's executing a few hundred times, you would definitely notice it's much slower. So this was, I think, 0.52. And then my next condition, so if it's not greater than 50 and it's not between 20 and 50, is it between 20 and 10? So we already know about less than 20. What we want to check and see if it's greater than or equal to 10. Then cost equals, this one was 0.48, and then else if, and then the next range was 5 to 10. So we want to know, we already know the 10 part, so we want to know if it's greater than or equal to 5, and in which case the cost is 0.45. And then for the last range, it was the less than 5. So as we said before, I'm going to use the else. It's not how I would typically want to do it, but it's kind of what we're stuck with for now, and that's fine. We'll make this better another day. So for the everything else that wasn't any of the above conditions up here, our cost was 0.4. So this should actually work exactly the same way as the previous version. So if, for example, I enter, don't forget to save, compile, execute if you're doing this yourself. So I'm going to enter the package weight of 4, and it gives me $1.60 like it did before. So that's not a surprise. So this actually works exactly the same. The difference is that it may or may not be more efficient. Again, if you happen to know that more of the packages were heavier, then this would be more efficient than the previous version. But if you knew more of the packages were lighter, then use the other version. If you don't know, then it doesn't matter. Just use whatever's most intuitive. So here's an exercise for you to try on your own. We've got an apartment complex that determines the cost of monthly rent as $500 plus an amount determined by the number of bedrooms. Write a program to calculate and display the total rent based on the number of bedrooms that's entered by the user. Go ahead and pause the video, try the exercise, and don't forget your IPO chart. Then resume the video and we'll go over the solution pretty quick. Okay, so hopefully you had a chance to try the exercise. We'll start, as always, with our IPO chart. So in the output section, we want to know what this program's goal is, what it's supposed to output. So in this case, it would be the total cost of monthly rent. There we go. And what input do we need in order to determine the total cost? We would need to know the number of bedrooms. And how do we transform the input into the output? How do we take the number of bedrooms and use it to calculate the total cost? We would then have to calculate the total rent, or total cost of monthly rent, whatever, equals 500. Obviously, we're going to need some constants for this program, plus the bedroom cost. And this was either, I think it was $250 for one bedroom, or it was $450 for two bedrooms, or it was $700 for three bedrooms. If you want to, you can assume that anything that is not 1, 2, or 3 can be an error or a bachelor apartment. You can make up a cost for a bachelor apartment if you want. Again, once we learn a little bit more about structures and error handling, we can actually do something better with that. But for now, we're just going to assume the user is going to enter a valid value. So here's a solution that I came up with. I added constants for the costs of the 3 sets of rooms. So one room is $250, 2 rooms is $450, and 3 rooms is $700. And I also made a constant for the base cost of $500. And then I went ahead and created the scanner, and I asked the user for the number of bedrooms. Again, you can check your IPO chart for that. And then I have my multi-sided if statement. You might have done yours slightly differently. Again, there's obviously more than one answer to this question. So first, I set up a variable to hold the room cost. And I didn't need to use any greater than or less than. I just said if the num rooms that I got from the user is equal to 1, I use the constant for 1 room. If it's equal to 2, I use the constant for 2 rooms. And if it's equal to 3, I use the 3 rooms. I didn't use an else because it's got to be either 1, 2, or 3. It's not going to be anything else. I'm just going to assume if it's nothing else, then, like I said, you could add some code that it's an error. I'll show you in a later lesson how to deal with that. We're actually going to come back and revisit some of these programs later when we do some error handling. So the next thing I want to do, once I have determined the cost of the room, again, put the minimum code possible inside these blocks. So all I need to find out is the room cost. That's it. Then after the if statement, I calculate the rent as the base cost plus the room cost. And then I do my output. I just output the rent. So if you save, compile, and execute, and I'm going to try each one of them. So I'll try first number of bedrooms is 1. It says 750. That makes sense because it's 250 plus 500, so that's 750. If again, you don't have to recompile, just execute it again. I'll try 2. So 950 because it's 500 plus the 2 room was 450. That's 950. And then execute one more time for 3. And it says 1200 because it was 500 plus 700 for 3 bedrooms. If you enter anything that's not 1, 2, or 3, then it's just going to, I think I initialized it to 0, so it'll just display 500. So it'll be base cost plus room cost. You can try it if you want. At least it doesn't crash. That's the important thing. So if I type, for example, 6, whoops, or okay, 5, because I had my finger on the wrong key, it just says 500 because it just added 0 for the room cost. Now Java has an additional multi-select structure called a switch statement. The switch statement can be more efficient than a multi-sided if statement in certain circumstances. First, the switch only works with the int or anything that can be implicitly cast into an int, so that would be byte, short, or char. And it also works with strings. A switch statement won't work with floating point values, and you should understand why once you see how it works. And in case you're curious, the reason why Java's switch statement doesn't support a long primitive type is because it's meant for a small set of values. In fact, even an int is probably too large. You would never switch for all of the values in an int, but it supports the int because int is the default integer type. The switch didn't even support strings until version 5, which was in 2004. That may actually not seem very recent to you, but it was pretty recent to me. It seems like only yesterday I was teaching the switch statement and saying, hey, guess what? We can use a string with a switch statement now. Like it was a brand new thing back then. Anyways, secondly, a switch statement works best when you want to check a single variable or expression for one of several values rather than ranges of values. Now here's the general form of a switch statement. Note that the expression must evaluate to either an int, anything that can be implicitly cast into an int, or a string. The expression must also be enclosed within parentheses. As we've seen with other structures so far, these are not optional. The parentheses have to go there. Also note that there's only one set of braces. They open at the start of the switch and they close at the end of the switch. Everything inside the switch are called cases. Each case checks to see if its value matches the expression's value. When a match is found, the code inside that case is then executed. The break statement is used at the end of a case to tell Java that it's time to exit the switch and move on with the rest of the program. The default case is optional. If you don't need it, then don't include it. The code in the default case executes if none of the cases match. It doesn't need a break statement because it's the last case in the switch, and this will make more sense once you see how it works. Let's do a very basic example of a switch. So here I've got a little program that sets up a scanner and then asks the user to enter a day number. So that would be, for example, 1 for Sunday, 2 for Monday, 3 for Tuesday, etc. And I'm just going to write a switch statement that examines the day number entered by the user in the variable day and then prints the word for that day of the week. It's very basic and very simple. So I start off with the switch, and in the parentheses, I put the thing that I want to examine. So in this case, it's the day variable. You can also put an expression in here as long as it evaluates to something that is, like I said, an int, byte, short, or char, or a string. You can put an expression in there as well. And then I start off with case 1. So this would be for Sunday. So I'm just going to do a system.out.println and then Sunday. Like that. And then once I print Sunday, I want to leave the switch and move on with the rest of the program. So I'm going to put a break statement. Because there's only one set of braces, you have to add these break statements between cases when you want it to finish after a case is done. So once it hits break, it actually leaves the entire structure, which is what we want. Later you'll see actually why that break statement is so important. So my next case, if the user, basically this says if the user enters 2, then I'm going to print Monday. Like that. And I'm going to basically do the exact same thing for each of my cases. Notice the indentation as well. We normally know that we should indent anytime we enter a block. All the code inside a block should always be indented. So we always indent inside a case as well. Your editor may not try to indent. I'm pressing tab to get my indent in there. Usually the editor is pretty good at indenting when it thinks it's supposed to, but with a case it doesn't. Some will, some won't. This is a basic editor, so it doesn't actually indent. We have to do it ourselves. Oops, you have to spell break correctly as well. All right, so I'm going to go ahead and finish the rest of this switch statement, and then we'll talk about how it works. Okay, so I finished the switch statement. So I've got case 1 for Sunday, case 2 for Monday, case 3 for Tuesday, 4 for Wednesday, etc., all the way down to 7 for Saturday. And then I have after, that's the closing brace for the switch. By the way, you're getting to the point where you're going to have a lot of braces and stuff enclosed in braces. And what I recommend some students do, if you get confused with where something begins and ends in terms of braces, put a little comment on a closing brace and just say like ends the switch statement. And then just so you know where it is, and the main method if you like. And then obviously that's going to be the class one, which once you start writing your own methods, you'll want to tag this too. So end of class. So I usually recommend, if this is something that's going to cause you trouble later, don't be afraid to add a little comment on your closing braces to just sort of notify yourself of what this brace closes. So in this case, it's the end of my switch statement. So I've got a switch statement, and it basically checks day, the user input for day, and then it'll print the day of the week. So if the user enters, let's say 5, then it will examine case 1, and it'll say, is 1 equal to what's in day? Nope. So it goes to the next case. Is 2 equal to what's in day? Nope. So it goes to the next one. Is 3 equal to day? No. Is 4 equal to day? No. Is 5 equal to day? Yes, I do believe I said we entered 5. So when it comes to the case that matches, it then executes that block of code. And I've only got one line of code in here. You can put multiple lines of code if you want. Just because I have one in this example doesn't mean you have to have one. You can have more than one, as long as you've got the break statement where it belongs. And I'm using the word where it belongs on purpose. You'll see why in a few minutes. So it will execute the print line and print Thursday, and then it'll encounter the break statement. When it executes the break statement, it looks for the closing brace of the switch and then continues with the rest of the program. So I added a little thank you message just so that we know when it has reached that point at the end of the program. So if we save, compile, and execute, and I enter 5, it'll do exactly that. It'll print Thursday. There it is. Now, if I enter something that's not 1, 2, 3, 4, 5, 6, or 7, then it will just print thanks. For example, if I enter 10, except I have to have, I don't know why my cursor, I just keep putting it in the wrong spot. There we go. If I enter 10, then it doesn't print any day number because it went through, there it goes. I wondered where that guy went. It goes and says, is it 1? No. Is it 2? No. Is it 3? No, etc., etc. It goes to 7. No. And then it runs out of cases. So it didn't actually get to do anything. It just prints thanks when it's finished. If you wanted to, you could add a default case at the end. It just goes like that, default. And then the default block will execute whenever none of the above matches. It's like the else in an else if. So I can say system.out.println. Oops, and I can just say, for example, error, whatever you like, invalid, something else. You can greet the user. You don't need a break because it's last. You don't actually need a break statement after the last one. So I'm going to save, compile, and execute. And I'll try entering 10 again. And this time it says error, because that's what I told it to print. So there we go. So that's basically how a switch statement works. Now, the most amazing thing about a switch statement is how the program flows through the cases. So to understand this, I want you to try one of the examples from the notes. So if you go into the notes on multi-sided selections and then go to the page on the switch statement, and if you scroll down here, this first concrete example, try switch, just take the contents of the main. So watch your braces. So that's the class brace and that's the main brace. We don't want that. We just want from here to int number equals 2. So take that if you want to try this yourself. If you don't want to, that's okay. And copy that into here. If you want to keep this code, that's fine. Just comment it out, whatever you like. I'm going to just cut it and stick it somewhere else. So in this sample of code, I've got int number equals 2, and then I do a switch on number. I'm examining number, the variable number, which I've hard-coded. You can get it from the user instead if you prefer. It doesn't really matter. And if they enter 1, I'm printing the word 1. If they enter 2, I'm printing the word 2. And if it's 3, I print the word 3. And if it's anything else, I say too many. So because it's initialized to 2, your thinking, and our thinking would be, okay, case 1, no, 1 is not equal to number, so it's going to skip this one. Case 2, is it a 2? Yes, this one is true. So you're thinking, okay, it's going to print 2, and then it's going to leave, right? Well, let's see. So if I save, compile, and execute, you'll notice the output is not what we anticipated. It's 2, yes, but then it prints 3 and it prints too many. So why on earth did it print everything from 2 onwards? What you might notice is there's no break statements inside this switch statement. Now this isn't an error. This is actually how the switch statement works. Once it finds the first matching case, which in this case is case 2, it will continue to execute everything, all of the cases, even the default case after that, until it finds either a break statement or the end of the switch statement. Again, this isn't a bug or an error. This is the intended functionality of a switch statement. So the reason why we get all this output is it found case 1 wasn't the match, so it went to case 2. It was a match. It executed the print line for the value 2, and then it actually executed the rest of the code in all the rest of the cases. Again, this is the intended functionality. So to understand why, let's imagine we wanted to write the code to determine the maximum number of days for any month where the number was entered by the user. So for example, if the user entered 5, which is May, we would want to display 31 since there's 31 days in May. And if the user entered 6 for June, then we want it to display 30 since there's 30 days in June. So we can do this with a switch statement. Again, if you want to comment this out or delete it, it's in the notes. You can grab it again whenever you want. There we go. So let's say, and again, whoops, I have an extra brace there. If you want to get the month number from the user, that's fine. I'm going to hard code it just to make this go a little bit faster. So I'm going to say month number equals 5, for example, and I'm going to do a switch on the month number. Opening and closing brackets. There we go. So what I want to do is I want to determine the maximum number of days. So I'm going to have max days and I'm going to initialize it to 0. So the first case I'm going to do is for February. Now we actually did a bit of code in an earlier video on how to determine the leap year. So I'm just going to borrow that code from that video. Again, this is something that we learned and talked about. So if you missed it, you might want to go back and look at that. So what I'm going to do is assign to max days. Max days in February, the maximum number of days is either 28 or 29, depending on if it's a leap year or not. So I'm going to use a conditional because why not? So that was the logic we came up with in the previous video on how to determine the leap year. So if that condition is true, then I want to return 29 and I'm going beyond column 80. So I'm just going to wrap this down here. So if that is true, it's going to return 29. Otherwise, if it's false, it's not a leap year, it's going to return 28. Now I don't have year, so I'll just initialize year to 2020, might as well. So, or you can get it from the user. Again, you can get either of these two values from the user if you want, but we have to have a year for this to work. And then I'm going to do the break statement here. So if it's the month of February, if the month is 2, then I'll either return or get the value 28 or 29, depending on whether or not year is a leap year. Again, I'm hard coding it, so it's kind of a giveaway. And it'll assign that number 28 or 29 to max days, and then it will exit the switch statement. And then I want to now take the next set of months into account. So there's 4 months of the year that have 30 days. That's April, June, September, and November. So April is 4, June is 6, September is 9, and November is 11. So for each of these 4, I want to set max days to 30. So I don't want to say max days is 30 break, max days is 30 break, max days is 30 break, max days is 30 break. That's redundant. What I'm going to do is put max days equals 30. 30. And then a break only under 11, because what's going to happen is if month had been set to, let's say, 9, it's not 2, so it's going to skip that one. It's not 4, it's not 6, but it is 9. And so once it finds the case that matches, in this case, case 9, it will go all the way through from 9 downwards and execute all of the executing statements, anything that ends in a semicolon, until it encounters a break or it runs out of stuff. It leaves the switch statement. So since case 9 would be true if we had typed 9 instead of 5, it will execute this line of code, max days equals 30, that will assign 30 to max days, which is exactly what we want. That means we can do the same thing. This is going to get kind of long. We can do the same thing for all the rest of the months. So we can do this for January, we can do this for March, we can do this for May, we can do this for July, and for August, and for October, and for December. Then max days equals 31, and break statement. And then what I'm going to do, just for the default, I'll just do max days is 0. Anything that's not a valid month number, I'll just sign 0 max days. Again, I don't need the break after the default. Because this gets kind of long, what I usually do when I'm in the classroom, or in this case in a video, where we need the space so that people aren't saying, can you scroll up? Can you scroll down? I can't see. I'll do this. This isn't actually a standard thing, but at least I'm not having to scroll up and down constantly so you can see all the code. I actually will sometimes do this in my actual code, but again, it's just to save some space. If you use a code beautifier or an auto formatter, it'll put it back the way it was. So what this will do is I have, where is it? I have month set to 5. So it'll go, is it 2? No. Is it 4? No. Is it 6? No. Is it 9? No. Is it 11? No. Is it 1? No. 3? No. 5? Yes! It found the case that's true. So from here on, it will execute all of the executable statements until it encounters the break, which means there's only one. It will say max days equals 31. Then it will say break. It leaves. And after the switch, we want to actually output our max days so we can see if it works. Like that. Okay, so if we save, compile, and execute, and it says 31. There it is. So it actually printed 31. If you want to try different values, for example, if you want to try September, for example, that should print 30 days. Save, compile, execute. There we go. We get 30. Ta-da! So that's a switch case. Notice that I didn't have to put my cases in numerical order. It's not necessary. You can put them in any order you want. It's basically like an if, else if, else if. I could have written this switch statement as an if statement instead, but it would be kind of ugly. I'd basically have if month equals 2, and then that would be I'd have to do all the leap year, etc., and all that kind of stuff. And then else if, here comes the fun part, month equals 4, or month equals 6, or month equals 9, or, am I going to have enough room? Month equals 11, and then it would be max days equals 30. Oh, I can't type today. And then, else if, oh God, month equals 1, or month equals 3, or, yeah, I'm just going to copy paste this. Hang on. Nobody wants to sit here and watch me type a bunch of relational expressions. There we go. And that would be max days equals 31. I have some pretty crap indentation happening here, but I'll fix that. There we go. That is tedious to type, obviously. So it's actually easier to type this as a switch statement. Even though it looks like there's more code, it's actually much easier to type as a switch statement rather than as an if-else statement. Now at this point, it should be obvious why a switch statement would not work with floating point values. So remember that floating point numbers are stored approximately. Remember when we talked about floating point approximation? So if I was going to do a switch statement with floating point numbers, for example, if I had some floating point number called foo, because we like to use foo, then what would I have? Like, if I wanted to check for the value of 1, I'd have to do a bunch of these, right? So remember that floating point approximation math that we did a while back? So this could be, I'd have infinite cases. It would be impossible. So this is why we can't do a switch statement with floating points. There you go. So in the notes, there's an exercise. Actually, there's several exercises and examples, and the one I'm interested in is this one, number 3. So question 3, a program is needed to calculate delivery costs to various provinces and territories in Canada. This is very similar to an example we saw on the slides earlier. So this table describes how the delivery costs are calculated, so you can see that the user is going to enter a province code. These are province postcodes, so NS for Nova Scotia, NL for Newfoundland and Labrador, etc. So the user's going to enter a 2-character province code abbreviation, and then your program should determine the delivery cost for that province code. So what I'd like you to do is do the IPO chart first, of course, for this exercise, and then try to write the program using a switch statement for this exercise. Do this question on your own and then come back to check your answers. So go ahead and pause the video, do the IPO chart, write the program, and then resume the video and I'll show you a quick solution. Okay, hopefully you had a chance to try this exercise. So here is the IPO chart. So of course we start with the output. The output of this program was the cost of shipping. The input that we needed was the province code, and the processing, how we convert our input into our output, is we determine the cost of shipping based on the province code. So let's take a look at the code for this solution. So of course I created my scanner and then I retrieved the province code. I kind of cheated a little bit here. So I used the 2 uppercase on the next method. So that takes whatever string the user typed. I converted it to uppercase just to make less code farther down. Hopefully you thought of doing that as well, because we've talked about this before. And then that means that code is always going to be an uppercase province code, which is great. So down here, what I noticed when I was looking at the chart was that the cost for Nova Scotia, New Brunswick, and PEI was the same as the cost for Manitoba and Saskatchewan. So I thought I would combine them into one set of cases. And you can do that. If you did them as 2 separate cases, that's totally fine, and that's legitimate because it's possible the cost could go up for Manitoba, Saskatchewan, but not for the Maritime provinces. That's entirely possible. So you're perfectly fine if you did them as separate ones. I'm just lazy, so I thought less code if I put them together. That means if one of these, if it changes for only one set, then I'd have to make a bit more modification. So that's kind of a drag. But anyways, it doesn't matter. Either way is fine. So for each of these 5 provinces, I assign the cost $29.95 and then I break. Again, I don't want to display it in here. I just want to assign. That's all. We display it at the bottom. If we display inside each case and then somebody says, oh, we need to change how that's displayed, that's going to be a lot of code to edit. Whereas my way, I only have 1 line of code to edit in that case. So then I did one for Newfoundland, was all by itself, so it had 1. And then the next set was Quebec and Ontario, so I did the $24.95. And again, all of these have a break statement. And then the Alberta, BC one was $37.95 and the break statement. For the last case, you could have done the territories as a default case. That's totally fine. I didn't. I don't know. Maybe I might want to add a default later to say invalid province code, perhaps, but it doesn't matter. If you did it as a default, that's also correct. So I did the 3 territories, $39.95, and because it was the bottom one, I didn't add the break statement. It's not necessary. Same thing if you used a default case instead, you wouldn't need the break statement at the end. And then it displays the cost. So if you save, compile, and execute your code, and I enter, for example, Ontario, I can type it in lowercase letters because I converted it to uppercase when I got the input from the user. So it says, is it one of these? Nope. Is it this one? Nope. Is it one of these? Yes. So then it does the $24.95 and that's what I get. When it finds the right one and it hits the break, then it exits and that's when it does the print. So there you go. So that's it for multi-sided selections and the switch statement. In the next video, we'll use everything we've learned about selections so far to create more complex logical structures by nesting selections inside each other. I'll see you over there. Thanks for watching.